Welcome to the lesson 7 of the Advent of SysML v2. This is a training series consisting of short videos and exercises brought to you by Sensmetry in collaboration with Vince Molnár. My name is Kestutis, and today we're gonna recap week 1, everything we learned in the first 6 lessons. We'll revisit 2 main areas. First, what SysML v2 is and the key concepts we covered: definitions and usages, specializations, modifiers and multiplicities. And second, how to work with SysML v2 textual model files, how to navigate them, format, refactor them using Syside and AI, and how to do version control in Git. Let's start with a quick recap of the core concepts. On day 1, we introduced the paradigm shift systems as code. SysML v2 textual notation brings systems engineering much closer to software engineering. It offers precision, expressiveness, and efficiency. This fundamental change means you can work with models the same way software engineers work with code, using familiar tools, version control, and automation. That's the real power of systems as code. On day 3, we learned about definitions and usages, fundamental concepts in SysML v2. Definitions classify individual things, like blueprints or reusable concepts. Think of a car, a marriage, an integer, or a procedure. You can point to the instances of these regardless of context. Usages classify things inside the context, like a car owned by someone, someone's first marriage, or a subroutine. You need the context to identify them. Here's the rule of thumb. If it's like a blueprint describing a reusable concept, it's a definition. If it's like a property or a feature describing a role in a context, it's a usage. And remember this important point. Usages are still types. They classify things inside the context. They are not instances. On day 4, we explored specializations. There are 4 types, each serving a specific purpose. Subclassification is between definitions. It lets you create more specialized types from general ones, like Santa sleigh from a sleigh. Subsetting is between usages. It allows you to define subsets of usages, like Rudolph as a subset of all reindeer. Redefinition is also between usages. It lets you refine inherited usages in specialized contexts, making them more specific. And the definition relationship connects a usage to its definition. It's how usages inherit features from their definitions. All of them restrict instances to subsets, enabling design refinement and reuse. On day 5, we covered modifiers and multiplicities. Modifiers give you fine-grained control over your models. First, abstract and concrete types control instantiation. Abstract types are skeletons that must be specialized before use, while concrete types can be instantiated directly. Next, composite and referential usages control ownership. Composite usages mean the type owns the value and parts are destroyed with the whole. Referential usages are just references. Values exist independently. Finally, variables and constants control changeability. Variables can change over time, while constants never change, like reindeer's nose color. And then there is multiplicities, which control how many values a usage can have. Understanding default rules is crucial. They are not always what you might expect. Now, let's talk about how we work with these textual SysML models. On day 2, we learned about Syside's powerful navigational features. The outline window gives you a high-level overview of your model structure, perfect for navigating large files. Go to definition, and peak definition lets you explore types and definitions instantly. Peak references show you all locations where symbols are used, incredibly useful for understanding dependencies. And rename symbol makes refactoring models efficient and safe. Code folding helps you navigate large models by collapsing sections that you are not currently working on. On day 6, we saw how text-based notation enables professional version control with Git. Visual diffs show you exactly what changed, line by line, with beautiful color highlighting. This is a game changer for professional systems engineering workflows. You can see what changed, when, and why through commit messages. All of this is possible because we are working with text files, and this opens up even more possibilities. Let me show you a practical example of what this means. We are going to solve challenge from lesson 3, refactoring the Santa's Workshop model. This will demonstrate how you can format, refactor, and improve your models incredibly quickly, something that's just not possible with traditional diagram-based tools. Here we have a poorly formatted SysML v2 textual model. To prove you that it's syntactically correct, we are rendering it in Tom Sawyer visualization. As you can see, visualization worked as expected. We can load the Santa Workshop child parts as S3 and view the attribute values for each elf. Now we're using the format document Syside feature. It, as you can see, fixes the formatting issue. It restores the nominal formatting, and this allows engineers to always make sure that the model that you receive can be restored to default values. Now we are starting to do refactoring. We already did the elf definition. We added the common skill type and skill level attributes with default values TBD, which was extended in the enum definition. Next, we are updating Santa Workshop part definition. Here we're just setting the first couple of Albert in particular we refactor it manually. So we set the redefinitions to the way we want the final model to look like. We know there's many elves, and we could do that manually to refactor all the other elves, but if it was, let's say, 100 or 200 parts, it would become very tedious task. Therefore, what we show here today is how you can do it, how you can use AI to assist with this task. We wrote a simple prompt just to update other elves like we did for the Albert. And now in Cursor ID, the AI, it reviews the models and then starts implementing the changes. As you can see, we are starting to review them, and one by one we start to accept them. So so the process continues, and Syside is providing the feedback to the AI. So that's how AI knows that the model is syntactically correct. And without Syside, AI is most likely guaranteed to produce output that is with syntax errors or with some other problems, and then the quality and the efficiency gains are not there. So here the Syside is a necessity for the AI to have information on whether the output produced is good or not. And finally, we render again the output in the Tom Sawyer visualization just to show that we have a model. It's now updated to use elf part definition for each elf, and we can view the attribute values as before in Tom Sawyer visualization. What we just saw demonstrates the power of text-based modeling. In just a few minutes, we went from a messy, unmaintainable model to a clean, well-structured one. This kind of rapid iteration and improvement is what makes SyML v2 so powerful for real-world engineering work. So what have we accomplished in week 1? We understood the SyML v2 paradigm shift to systems as code, which enables software engineering workflows. We've learned to navigate and work with textual models. We mastered definitions, usages, and specializations. We applied modifiers and multiplicities for precise modeling. And we integrated version control into our workflow. This concludes our week 1. I encourage you to practice what you've learned so far. Take the challenges from each day, merge their models into a single file, and just experiment. Share your results in the community forum, and also feel free to ask any questions about any of the lessons. Links and information on how to access the Syside Cloud Platform are in video description below. subscribe to our YouTube channel, click on the bell icon to get notified about future lessons. Next week, we'll dive into more advanced SysML v2 concepts that build on this foundation. Until then, take care and happy modeling!